Welcome to Thoughtful Software. My name is Fahad, and today we're going to talk about machine learning and artificial intelligence and data biases in machine learning, which is not often discussed. We're going to talk about diversity as well, so it's going to be a really interesting discussion. All right, here we go. Hey, Andrew, and Chris is also joining us today for the first time. Let's talk about machine learning and artificial intelligence. This is always a hot topic. Maybe setting the baseline of where these different types of technologies fits into an organization.
Yeah. So about 10 years ago, you start to see enterprises and businesses put more value on the data they're collecting from their systems, ERPs, CRMs, name it, they were collecting data. And you started seeing systems get installed for big data. Right? Everyone had big data problems. You see your Hadoops getting installed, all the types of systems on top of Hadoop, Mahout, things like that. And as problems in the enterprise became more sophisticated, you started to see more sophisticated techniques being applied. Machine learning, people seem to think that's been a new thing. It's been around since the 70s in the academic world. But now people actually had access to the data. And I see where they got access to the data was as they were building out these big data systems, they were actually building data science teams. They weren't called data science teams. They were just your people that wanted to mess with CSVs their entire lives. But as you had these people, you were able to build and create these data pipelines that put the data in the right format for these machine learning techniques. And then as we continue, we started seeing more and more classes of problems with the data. Natural language processing takes care of the text data. The more advanced algorithms like neural nets being used at enterprises. And where you are today, what we call AI is actually a technique called deep learning. And what deep learning is basically a neural net of neural nets. And that's where we are today. That's kind of like the state of the art. Well, there's a lot that goes into deep learning. Like there's auto ML, which is a technique where you use machine learning to kind of learn how to machine learn your data. But it all comes down to the core competency of, can I get my data in the right format? Can I provide the right data to the algorithms to actually have the algorithm turn out a reasonable result for what I'm looking for?
But let's talk about where this, like if you're an organization or enterprise just getting started or have been using these traditional teams, data teams, and now you want to build out a data science team, like where's a good starting point? Because I've seen companies invest a lot of money into data science, and after 6 months or 9 months, these really expensive engineers basically come out with nothing. And it wasn't really thoughtfully understood like how these teams should be put together.
Absolutely. So as we're walking through this I did a project with this with a large enterprise last year. I'm still under NDA for, so I can't talk about the name. The first thing I always suggest is to do a data inventory. Is it even worth having a data science team? Do you have enough data that's accessible, right? You might have the data, but Oracle might own your data or Salesforce might own your data. And so you want to know, what data do I have? How much of it do I have? And is it meaningful? And so for these kind of data inventories, I always like to say we need business experts, right? Ultimately, if you have data, that's one thing. But to make that information, you need to transform that data into something meaningful. And without the meaning, aka someone that knows the business, a business analyst, or just a subject matter expert in how the business operates, you can't get any meaning from the data. So you don't know what data is valuable or not. That's the first step. I think the second step you want to do is, if you have meaningful enough data, what answers are you trying to look for in your data, right? You see solutions like Tableau, Domo entering the space where you can see and visualize your data to help answer questions that you might have about it. And taking a step further, once you have those kind of questions, there may be questions you can't solve with simple data visualization, that it actually needs a computer to break down the answer because it's just so complex. And that's when you start getting into things like MapReduce, Hadoop, and potentially machine learning, or in some cases, deep learning.
So if we go back a little bit, right, and we look at how do we get started with this, I think from my experience, the most so people have started like they would a agile software project, right? You need to start with a small experiment. Have some sort of hypothesis, right? Like, hey, my data can predict this very small thing, but let's try that very small thing and see. Let's just see where it leads us, right? And those small experiments can tell you very early, like, this is not going to work for us, or hey, we have a glimmer of some sort of results here, so we should proceed forward. So for me, that's the first step is treat this like an agile software project.
But let me ask you about the algorithms itself, though. Like, even if you want to go down this road, what is the significant advantage of let's say just a machine learning algorithm as opposed to something that people have been doing traditionally? Like, what are the gains that you're getting out of using this new technology?
Yeah, so if you look at where AI started, right, the first AI revolution was in the 80s or something, late 70s, early 80s, right? And what they were producing is a bunch of what would have been called expert systems. So they were looking at sort of data then, and they were trying to build mostly like decision trees, right? So what process an expert in the field would go through to find an answer. That has evolved now that we're in the second AI revolution into actually looking at the data using statistical techniques, right? And so that's, for me, modern machine learning is applying statistical techniques to the data that you have.
Well, let's talk about this. So now that you have a data structure, you have a team. I think this whole topic got started, last week we were talking about something that's interesting that I don't think many people do talk about, is actually bias in your data. And you see things like where people have complained about Pokemon Go, where there were fewer Pokemons in, you know, like different neighborhoods, and like because the developers never went into those certain neighborhoods, and so you see like different biases that happen there. Where how do you clean that up, or how do biases get introduced, and then how can you make sure that doesn't happen to your data?
In my opinion, the way you get rid of bias is a simple question: what bias might exist in the data? There are a lot of, as Crystal mentioned, a lot of statistical techniques that will help you get it out. Once you kind of can consider what type of biases. So you're dealing with geographical data. What kind of biases can be existed in the data set that you have? And once you start thinking along those lines of what kind of biases may exist, I believe you'll be able to solve the problem. There's already techniques that exist in biology and physics and all the other hard sciences is what they're called, I guess, that aren't being used today. And I think it's just because the ethical standards for the algorithms we implement in computer science aren't quite the same level of scrutiny that exists in the other sciences, which is a shame if you ask me.
I just want to get to a fundamental thing about what we believe is thoughtful software. And there's one way to get rid of biases, but how do you actually implement I guess a philosophy that you don't have biases in the first place? Like Pokemon didn't know that they're not going to have enough Pokemon in, let's say, you know, maybe some of the lower class neighborhoods. They didn't even think about that in the first place. Yeah, going backwards and fixing it later, but how do you kind of build that in the first place?
I would say it comes down to just building it into your process, right? For other sciences, you can't get rid of bias in your data, right? If you look at any biology paper, physics paper, chemistry paper, people acknowledge the biases and how the data is collected. And why they do that is because it's impossible not to. We're humans and we're fundamentally flawed. So, but if you're not forced to acknowledge those, you don't build those in your process and you don't recognize that they can exist, then yeah, you're going to have to go back and fix it. But if it's in the process, if you disclose how you're collecting your data, how you did it, your methods and your means, then people can, one, check you, right? The community can check you. And two, you can check yourself, right? And that's the important. Are you looking inward and saying, well, how did I do this? What biases may I have had when I collected the data, right? Because we all want to be right. We do research and we write algorithms. I mean, we all want to do that. Or if you don't want to be right, I kind of question your ethics to begin with. So if you're trying to do things well, I think this is part of doing things well, just having that be part of your process.
Yeah, so I definitely agree with all of that. So I kind of look at it just a little nuanced view on what Andrew was talking about is I look at there's biases in data, And we can identify those using statistics, right? So that's the central limit theory. Um, we use those sort of statistical tools to see whether or not the sample that we have, when you compare that to the population as a whole, does it actually match what it should, right? So there's tools in statistics to measure biases in the data itself. I think the more troubling thing, and this is where I think Andrew's going, is the actual framework around the data and how it's interpreted. And that's where there's a lot of room for trouble, right? So in getting ready for this podcast, I decided like, hey, I should look and see what sort of research is out there on implicit biases and unconscious biases in data science, right? So I go to ACM and I search for those two terms, and I get a total of like 15 papers between both of those search terms, right? And so I think like, well, maybe ACM's not the place I should look. I'll go to IEEE Explore. I'll look and see what academic papers they have on it. They had even fewer. So 4 on 1 on implicit biases and I don't know, 3 on unconscious biases. So maybe, so I thought maybe I'm not even looking for the right thing at all. I'm going to go to JSTOR, which is where the rest of the academic world publishes their papers. And when I searched for the two terms, I got somewhere like, I don't know, 25,000 results for one of the terms for unconscious biases, and then 90,000 results for implicit biases. So in our industry, it seems like people aren't considering that this is even a thing. At least if you just look at the published research, there's not people doing studies to say whether or not implicit biases or unconscious biases are actually impacting what they do on a day-to-day basis. And
Yeah.
I think that's where Andrew was going.
There's actually an example of this over the weekend. The HUD, the United States Housing Urban Development Department, filed a complaint against Facebook because they weren't showing housing ads to certain classes of people that violated the fairness rules we've had in place for, I don't know, the past 40 years. Now you can blame Facebook. You can't blame somebody because the algorithms are based on data, and the data themselves, they pulled from, just advertisement in general and who's using what. But that's the kind of thing that if you don't remove, you can be breaking the law. In this case, they were, right? They might get sued by the department or the state. And if that happens, who knows the cost of that, all the way down to just, losing users. Facebook has been dragged through the dirt a lot recently. And this is just another blemish on their record of like, well, if they had been a little more careful, this might not have happened.
Well, I think I think though it's interesting you make a point that it's not somebody, it's just data. But I think the root of what we're talking about is really people don't understand how important diversity is at a company. When you do have people with different backgrounds, different ethnicities, different genders, you do get this kind of level setting where they will somebody from, let's say, these neighborhoods might have a better understanding of what the user might be. I was reading something about like self-driving cars. If there's not enough women in this industry, the cars may not take into account to how women may drive cars differently, and that could impact these algorithms, and it could impact safety maybe. And I thought it
Oh,
was interesting that it comes back to how diverse is your company, and the people working on these problems.
I think
absolutely.
that's a great point, Fahad. It always bothers me a little bit when people say things like the data speaks for itself, right? Because the data it's just data. Some person has to make meaning of the data, and however they make that meaning, they're going to implement that into an algorithm, and that person's meaning is going to be propagated wherever that algorithm goes, right? And I think you make a great point. More diversity is definitely something that's needed to help mitigate that.
One of my favorite books of all time is How to Lie with Statistics. And it goes through like hundreds and hundreds of pages of just different ways you can use statistics and drill ins and lookouts and mediums and means to basically tell a completely different story with the data. There's also a website out there that's Causation versus Correlation. And they basically just correlate a bunch of things like consumption of ice cream in Maine is correlated to murders. And so the consumption of ice cream goes up, the rate of murder goes up, right? And you can do all kinds of things like that with statistics that like make zero sense. Of course, ice cream isn't correlated with murder, or I hope not. It's really weird. The people, like Chris said, information or data speaks for itself, and it's really information is how we interpret data, and information is used. I mean, just look at how people interpret the news. Just turn on MSNBC, watch the same thing, and turn on Fox. And it's just the same set of data, two different pieces of information were pulled out of the same set of data, and it's crazy. It's like you said, data speaks for itself is such a lie. It's just untrue.
Yeah. So, and Andrew brings up some good points. Is that it used to be fairly common that when you were building expert systems, you would have to work with an expert, right? So you have a computer scientist or a data scientist and an expert in the domain, and those two are going to pair together and build this expert system. And nowadays, that should be more common, right? You should have a domain expert as part of your data science team. So if you have a data science team and there's just data scientists and engineers on it, you're probably in the wrong. You're probably going to make a mistake because you don't have a domain expert. Make that mistake of correlating ice cream and murder or something crazy, right? Because you're not an expert in that domain.
Yep. It frightens me if you look at a lot of people that are data-driven, AI-driven startups, how few of them have business analyst openings. When I was doing my startup for Broker Savant, we worked with real estate agencies all the time. And me, I'm not a broker. I've never sold real estate. Our CEO had sold real estate for 15 years. And so regularly when I was looking up how to pull data out of a lease, I had to talk to him and like, what does this mean? What does triple net mean? Things like that. And it were questions that would take us hours. And it was painstaking, but we had to make sure we were pulling out the right clauses, the right dates, and all of that because we were doing it for regulation. People needed to report this to the federal government. And if we were wrong, the cost of being wrong was roughly, I think, like $1,000 per $1,000 per 100 square foot or something like that of real estate improperly registered. So we could have cost our customers a lot of money and time if we reported incorrectly.
So in terms of like being thoughtful, which is our theme, you're saying that industry experts, specialists are always more helpful. We talked about diversity, but having those types of people who understand, the industry can mitigate some of these like biases and issues that come up with these outcomes.
Absolutely. I harken back to, how many engineers do you know have pivoted away from a different career path? We have one that works at Skiplist, used to sell lumber at his family lumber company. And that experience gives him a lot of diversity because he's seen a different industry. But very few software engineers have actually worked in a different trade or a different job, right? How many people have been a bank teller or a semi truck driver or, pick your career path, and then they're turned and asked to model that information, but they've never done the job. That's not to say they can't. They just need to work with someone that has, so they can understand the nuances, right? It seems simple. You get in a truck and you drive it across the country, and boom, you drop your stuff in and you drive it back. So simple. But when you actually watch a truck driver do it, there's so much more to it than just getting in a truck and driving across, right? There's so many configurations of the semi, the weight of the semi, the regulations and rules in each state. And so modeling transportation, even it seems trivial, it's actually incredibly complex. And so you can't just trivialize it and say it's just driving. How hard could it be? I think a lot of people do that. It's the wrong way to do it, and it's not being thoughtful.
That's really interesting. So I was talking to someone who runs a data science team, and he was mentioning something to me very interesting. He said he prefers not to hire these really smart data scientists that come out of these top universities. He's like, he was trying to look for, I don't know if he was generalizing, but he said to be a good data scientist, you need to be a good entrepreneur, right? And really think about the business and, what issues that could come up because basically you're trying to investigate data with these algorithms, and you need to have that sort of mindset. And he said it was really hard to find those people.
Yeah. Well, it's hard to find the people that are willing to take the time to really understand what they're working on in general. So if you sit down and you start working on a project, one of the first things I do is I ask to speak to someone that does the job. I will sit. We were working a customer service application. They were for a big enterprise last year. Same enterprise we were doing data science for. We were redoing their customer service rep application. I sat with them for probably 12 hours or across 2 days, or yeah, 2 days. One was 8, the other one was 4. And just to watch them do their job. All I did was take notes for 2 days because I really wanted to understand how they were using their system. One, so we could build a system that worked for their workflow, but two, to really understand the job. And I still felt after going home that week from Denver that I didn't really understand what they were doing. So I went back 2 weeks later to do it again to truly, truly, truly understand it and make sure we are building the software the right way. And if you're doing anything less, it's, design is very common practice in UX UI design, but it's not really a practice in data science, but it really should be, because it's almost the same thing. You're just, instead of looking at how they're experiencing the system, you're looking at the output of the system, but really they're one and the same. How the user experiences the system is how they're going to create output in the system. And so it's really in and out. And both sides of the party need to understand exactly.
Yeah, and to go back to your the person who's looking for people who are more entrepreneurial, that makes a lot of sense. That resonates with me because I know that I've been in situations where I'm like, okay, this is clearly a classification problem. We're gonna get some data and we're gonna classify it, and everything's gonna work out fine. And then you get into, you're like, man, this is really not working, and you have to step back, right? It's easy to step back and say, okay, this classification technique is not going to work. I'm going to use a different classification technique. And then sometimes you have to pull back, way back, and say, look, classifying this is not going to work. We need to cast this into a search problem instead, right? Or we need to change how we're thinking about the entire problem, right, from a very high level. And so somebody with that sort of entrepreneurial mindset is probably going to help in that area.
What do you guys think about these cloud services, like Google Cloud and Azure, that have these off-the-shelf, algorithms already built in? Like Chris, like I think recently you're working on a computer vision project, which, there's been some issues with, the images being classified in incorrect way, and claiming that some of these algorithms are actually racist. And like as you're building systems out, you got to be mindful of that. So how do you look at problems like that? Or I mean, what do you think of the services, and then kind of normalizing the data when you see it?
So let's start with the services, right? I think it's great that we get these tools out there. I think that's a great thing. It's always great to have tools into more people's hands because you have more opportunity for great things to happen. On the flip side of that, now you have tools in people's hands that may not may not be trained in statistics, so they don't know sort of where they're going with statistics on their data. They may be coming to conclusions that they really can't hold up. And they may not have this sort of understanding of the biases that they are bringing to the process, right? So it's a double-edged sword of great that it's out there and more accessible, but also you could have these in less trained hands making decisions that may or may not be the right decisions.
Yeah, and I'll back that up. I think it's really easy to get machine learning into your application now, which is going to be great for all the users. But you really worry if you're guiding someone through a process and you're advising someone to do something. Well, so let's say I built a smart CRM system to compete with Salesforce. If I advise someone to make a phone call that loses them the deal, that's kind of on the system. Now, you could say that the system just told the user and the user actually did it, so it's the user's fault, but I don't like to think like that. We should make systems that help our users and not hurt them. And when you're just giving tools to people, right? If you give someone a hammer, everything's going to become a nail. And so we have to be very thoughtful in how we give these users these tools to people and make sure we describe exactly how they should be used, and not just everything becomes a computer vision problem because I have this cool thing over here that's really cheap. You see it a lot in what I call word soup and like innovation labs, where you'll sit down and people be like, oh, we're going to use computer vision and we're going to use AI, we're going to use deep learning. You're like, well, what problem are you trying to solve and why do you need them? Instead, they start with a solution and work backwards to the problem. And that can be disastrous.
Yeah, so I remember when I was in grad school, and I was doing a machine learning class, and one of our professors had sort of a trick question, right? And this question was something like, here's your data set, and essentially it shows rain for, I don't know, 183, 185 days out of the year. Um, what's the easiest way to generate some sort of machine learning quote system that's going to give you at least 51% accuracy? Well, the easiest way, given the data that we had there and the requirements of only 51% accuracy, was to always return true. Because if it rains 183 days out of the year and you always say true, you are going to get your 51% accuracy, right? So the thing he was trying to teach us was precision versus recall, or ROC curves at the time is what we were looking at. But there's more, there's a lot that goes into it and how the data is interpreted.
Well,
Yep.
that's interesting. So let's talk about an enterprise. How do you actually prove out an ML project? Or how, you want to make a proof of concept. You make it a subset of data, or you make it the entire data set. And I'd be interested in like the pros and cons of something like that. And then how do you actually prove out that this actually worked and we should invest in some more budget and moving it to a larger scale? Like, what does that process look like, and what's a successful?
Yeah, I think the way you prove out ML is it's the same way you prove out any other project, as Chris said earlier and alluded to. Starting out with a very agile technique, what's the minimum thing I can build to prove I either have enough data, right? Is it a data problem? Is it what I call a tractable problem, meaning it can actually be solved? Or what am I dealing with before you even try to prove out and sell to somebody? Prove you can do it, right? On a limited subset. And we're working, I'll let Chris talk about the dashboard problem we're working on for one of our clients, but we're very much worried about the feasibility of anything that comes across our desk, especially when it comes to newer science like machine learning or natural language processing or deep learning, because it could just not be viable at all.
Yeah, so definitely. So we're looking at one project right now where, we definitely have that concern, right? Because we have a sort of proof of concept. Can we get this working? And we can definitely get it working, but we're looking at such a narrow slice. It's not statistically clear that we can make this work for the entire population, right? So we know that our proof of concept doesn't necessarily translate into success for the entire population. We think it will. So we will expand our proof of concept, right? So this is like first step. Does our proof of concept work? Yes, we can make it work on this very narrow scope. Okay, let's understand that that doesn't automatically translate to working for every single situation. So let's find another situation where we can take another small step and say, is it going to work now in this new situation? And if it does, is it the same approach? Do we have the right generalization of the approach? And we start building that confidence. Now we're having two different subpopulations, and they both work in the larger population, right? That gives us some validation. So iterating and continually bringing more data to the problem that's the approach we're taking, and I think it's going to work. Time will tell.
Yeah, and that's what you want to do for these kind of projects. I think one thing that happens is, especially at larger enterprises, what I like to call entitlement money, which is, here's $300,000, go just do it. And people burn their money, trying to prove the feasibility. And what I like to do for these kind of projects, start somewhere small, give me 20, 30K to work with. And then once we prove out we can do something, give a little more money, maybe 100, 200,000, right? And then you can prove out feasibility at a bigger scale, and you continue to grow it piecemeal. So you're not just burning money on experiments, because machine learning is, as we alluded earlier, is basically applied statistics and trying to turn data into information via a computer. What that information is, we don't know yet, right? What kind of information can we get? And usually there's a target. And so how do we turn that data into information? And we won't know. And so it's a series of experiments until we get to, if we transform the data like this, and we use this algorithm, we get the information we want. The computer can tell us back what, maybe we already know, right? So if you're using a classification problem, you should already know what the classification you're looking for is. And so then you have now have a repeatable process. How you got there? Lots of small experiments, right? And always you're looking for small experiments. So cool tools like IPython notebook, Jupyter notebooks now, that help you with these experiments and documenting them just like a scientist would.
How much of it is like an art? That through experience, what levers to pull and where to kind of tune it. Because I mean, you have certain accuracy. Let's say your POC uncovers a 60% accuracy, and then you slowly inch up to, let's say, 70% or 80%. When do you I mean, what are the levers that you're pulling, in terms of, the experience that you have? But then how do you kind of decide, is that good enough, or do you need to
Uh,
look at something else?
there's a bunch of answers here. The first is looking at your data. There's some really cool tools to remove bias as per set of statistical tools. There's something called feature analysis. So a feature is just basically a column of data or a field of data in your data set. And you can use things like principal component analysis or independent component analysis to pull out the data that has the least amount of entropy in it. I define entropy as loss of information. So as we use more of that field, the algorithm stays consistent. So we can really analyze the features of our data and figure out which ones we want to use and which ones we don't. And then the algorithms themselves have different variables in them that you can tune and tweak and really change your results based on the data you're looking for. All of that combined allows you to kind of tweak things, run against your data and look at it. And then you can use techniques like cross training in classification problems to really then build up your confidence in your algorithm and your percentage. So there are a lot of techniques. So that part is all science. The art form that you're talking about comes from experience of like looking at different data sets and knowing, hey, this technique's going to work and this technique's not. And that art form comes from years and years of just looking at data, 8 hours a day and putting in your hours. It's a lot like seeing engineering problems. Like I see an architecture and I kind of see what it is. I've been doing architecture for a long time, and data science is the same.
So Andrew knows me. I love principal component analysis, right? And it brings up, before I get into where Andrew is going, another aspect, another thing that we can do when we are sort of trying to figure out where to go with a bunch of data that we have, is that we can use tools like principal component analysis to reduce the dimensionality, right? So maybe we have and try and identify what are the most important aspects of the data set, and we use a principal component analysis to do that. But what it could also let us do is bring things down into a very low dimensional space so that we can we can actually just plot it out and look at it and say like, oh, it looks like there is a correlation, right? Like I can see it in the data that I'm plotting, or I'm plotting this data as all over the place. This is meaningless, right? So we can definitely use visualization tools to help bring some additional meaning to the data that we may have otherwise missed. And if I go back to how much of this is art, I can see how there's some experiential. It's valuable if somebody has a lot of experience and they know exactly what to do. But for me, it comes down to math and understanding the math of what's happening for the scenes, right? So, yeah, I mean, I guess you can call that art, but I think somebody who has a good understanding of the underlying math has an intuition for the math. And then that translates into success in the algorithm, because what's going to happen is when you're looking at large data sets, I mean, you have so many dimensions, you can't visualize any of that, right? So somebody who has a good feel for the underlying math can say, okay, maybe I can't understand what's happening on 5,000 dimensions, but I know how this should look when it was in 2D, right? And so they can understand where the data is taking them, because they can sort of generalize from 2 dimensions into this multi-dimensional space, their understanding of math.
Yeah, and I'm a big fan of putting like a cross-functional team together for these kind of problems. And what I mean by that is, we're a consulting company, so we usually don't have too many domain experts here. We have a few in a different domains, places we've worked, but we don't have like hundreds of people that know your business. And so I like to pair people that understand the math, people that understand data really well, and the things you can do with data. So real data scientists, and then a business analyst from the business we're working with. And that pairing, when they're all in a room, magic starts happening. People are whiteboarding and they're able to explain things to each other and validate ideas and validate other ideas and really come to a common understanding. And there's science involved and there's art involved, and that's when beauty happens. And that's when thoughtful things can happen too, right? So the those cross-functional teams, I believe even if you include a software engineer in there, someone that works on web apps or how this thing will be used and exposed to the internet, you get even better results. And that can be awesome as well. But I think it's folly to like take your AI people and put them in a room by themselves and say, write algorithms, and take your data people and put them in another room and tell them to process data, and then take your business analysts and put them in another room. I think you're just going to come up with a really poor result. And that's what happens at a lot of places, is these silos.
Yeah, I think that's a great principle, Andrew. Sort of everywhere you look, if you don't have a cross-functional team, you probably have some blind spots.
I think wrapping up, I want to get back to a point I said probably 15 minutes ago, which is if all you have is a hammer, everything's a nail. And I always want to caution people that not every problem is a machine learning problem. Sometimes you just have to return true and it works. I think a lot of people haven't earned the complexity yet of machine learning, and they should use other techniques. There's a lot of great mathematical techniques, as Chris alluded to, that will solve your problems. Netflix's movie recommendation engine used to not even use machine learning. It used matrix math. And it was just a giant, there was a good publication on it. And it had no machine learning whatsoever. It just used a bunch of data and multiplied two giant matrices together and created recommendations through that. And it worked really well. Now I think they're using some deep learning for it, but they've also earned their complexity as an organization.
Yeah, I think that's a really interesting point, because I think a lot of consultants will try to sell you on this big, big project and a lot of complexities. And I think a couple of podcasts ago, you talked about, a company that wanted to build some chat application. And you said, why don't you just download Slack? And I was like, that was it. Instead of like spending $500,000 building Slack, they're like, why don't you just go download it? And there are probably easier ways to analyze your data than hiring a team of 5 data scientists. They probably should investigate that first.
Yeah, I definitely agree as well. So I remember in school, that's one of our professors told us, hey, you should be able to do Bayesian analytics, Bayesian analysis, because a lot of times that's going to give you a rough enough estimate from the beginning. And it's just very simple math, and you'll get a good idea of where this is headed.
Yep. And they're great, as you mentioned earlier, off-the-shelf tools that will get you started before you go out and hire 3,000 people to become a digital ML powerhouse that you want to become. Start simple, as we mentioned, agilely, solve one problem at a time, and then you'll earn your complexity and you'll know your domain better. And then you can start hiring people, making sure that they're working on the appropriate things. It's very hard to hire for general purpose problems if you don't know problems you're trying to solve, or problems you can solve with the information you have. So my advice is always, always, always use off-the-shelf products until they don't work anymore, right? Use Tableau to do your dashboards until it doesn't work for your use case anymore. And then reevaluate, is there another tool that can work? Can I buy it? Or do I need to hire someone that's an expert dashboarding and bring them in and have them write on my dashboards for them? And that can really help you. Don't build Slack by Slack, right? Slack knows what they're doing most of the time, I think, and they know how chat should work, and you know how your business should work. And so stay focused and solve the right problems, and you'll win. I mean, that's it at the end of the day.
Thanks for listening to the Thoughtful Software Podcast. You can always check us out at skiplist.com. All right, talk to you next time.